Sharon has a BS in Geosciences from Penn State and a Master's in Education from the University of Buffalo. She's a geologist and also an educator, focusing on science and society. As a writer and podcaster, she advocates for science appreciation and critical thinking. Her specialty is researching anomalous natural phenomena, as well as paranormal culture. Sharon's new book is Scientifical Americans. Here's a copy here. The Culture of Amateur Paranormal Researchers. It was published just last year by McFarland Press. Sharon is the creator of DoubtfulNews.com, SpookyGeology.com, and is the host of the podcast 15 Credibility Street. Additionally, she's the owner of Lithospheria, a scientific consulting company, and her personal website is SharonAHill.com. So it's known that during severe thunderstorms, particularly if hail is falling and the sun is low in the sky, the clouds can take on a really sort of an eerie greenish cast. And certainly following solar eruptions, a few days later, high and mid latitudes of the Earth, if we're lucky, you can see brilliant flashes of green and red, the auroras that will take your breath away. So it makes sense that following the release of the tremendous amount of energy in some of these major seismic events, that people will see earthquake lights. But if they're real, why haven't they been better documented than they have? If they're unreal, why do people report them so regularly? A number of years ago, geez, this was following the tragedy of the Challenger launch in 1986. A friend of mine was at the launch, called me about 2 hours later, said he had taken a photograph and there's a splash of color that just seems odd to him, and wanted to know if I could help him. And I explained, sure, just send me the photo and I'll take a look and pass it on to someone who really might be able to, might be interested. And he said, no, you don't understand. This is hot. I need to know now. And I haven't even seen the photo. And I said, well, just tell me what's there. And we talked a little bit. And as it turned out, I asked him with the sun position, and yeah, he had taken it. It wasn't exactly on the launch site, so he had taken it through his car window. And I said, well, it could very well be a lens reflection or a camera artifact. And his response, well, how can you be so dismissive? You haven't even seen it. Sure enough, later that night, he had made it back to the DC area and was on the local news with a reporter showing him his photograph, and they were going over it in some detail. The point is, he really did want to help. He did see something, wasn't sure what it was. He wanted to help. I think more importantly, he wanted to be in the mix, wanted to make a difference. And sometimes separating what's real and what's unreal, it can be tricky business. So here to tell us more, please welcome Sharon Hill.
Thanks, Jim. I'm glad you started with that story. It sort of frames what this topic is sort of all about right now. As you said, my background is a geologist, and my area of expertise is science education, and specifically science in the public. But in my leisure time, I do research the scientific aspects of paranormal topics. I know that blows some people's minds, but I do look at ghost sightings and haunting experiences and sightings of strange animals and anomalies. That's what I love to do. But I really love natural anomalies and tales of extraordinary happenings, and that's how I ended up with you here today. So I just want to frame a bit about where we're going with this talk here. I did pull out all the latest literature on earthquake lights, and this is a topic has quite a bit of highly technical literature, along with being popular with lay audiences. And there's this spectrum of knowledge and understanding. And much information is in the specialized literature, but this isn't usually what gets to the public. And the accounts I relate to you today in this talk are taken from scientific journals or recent media reports. But I'm going to try to stick to this middle ground of knowledge. It's basic scientific understanding. I'm not a geophysicist, so if you ask me questions about geophysics, I'm not, unfortunately, going to be able to answer that. So pretty much today's talk will be non-technical. There are some highly technical explanations for these things, but the people who are making them are also very qualified experts, but I can't really talk about the physics of electromagnetism or the ionosphere, though I will mention them. But I want to examine these claims in the context of how it relates to the scientific community and scientific consensus and the public who's viewing this or reporting these phenomenon. So this will be a guide to the current state of thinking on the topic. And I'll try to hit the big questions. Is there something here to explain? And what are some reasonable means to explain it? And a sub-question is, what does the scientific community think in comparison to what the public thinks about it? And, you know, maybe mainstream seismology is missing something, or maybe it's all misperception or misinterpretation of other things. And I think perhaps, you know, some contribution from other fields might help unlock some of these answers. And then I'll close up with what the future may hold. Saucony, Quebec, Canada, on 25th November 1988. It's darkness. It's 1846 local time. Joseph Daillaire, a trapper who lives in La Terrière, was leaving the conifer forest near his home after checking his traps. The weather was mostly cold, clear, low wind. After exiting the woods, he was heading to his house across the open field, 700 meters away, when he was startled by a crackling sound approaching him from behind, followed by a curtain of bluish-white light that passed by in about 2 seconds, 6 to 15 meters high. And then he felt the shaking from an earthquake which had occurred 19 kilometers away, magnitude 6.5. He described the light as hugging the ground as it moved past him, passing into the open field and disappearing to the northwest direction. And Daillaire estimated that the sheet of light traveled the distance from the edge of the woods to his house in about 2 seconds. And he reported that the light was bright enough to illuminate his house. So the light traveled slower than lightning. There was no storms in the area, but the crackling suggested an electric field buildup, possibly discharge off the tree branches, and the curtain or sheet of light suggests that strong electric field that led to possibly discharge at the ground-to-air interface. And the discharge was traveling away from the direction of the quake epicenter. So what can we make of this quite remarkable event? It was not the only luminous phenomenon noted in association with this quake, which, if you think about where Saucony is in Quebec, it was within the continental landmass, not a plate boundary. It was deep at about 29 kilometers, and there was strong shaking, but few aftershocks, indicating there was this rather distinct release of energy. And these earthquake lights associated with this quake swarm were relatively well studied, but still we have this mystery on our hands. So what do earthquake lights look like? Well, they've been reported for centuries. Galli, he got 148 observations during 19th century Italy, Montandon developed a description system that is still basically used today as an outline of what these things look like. And they didn't have today's modern, well-lit electrical cities, and there were reports of lights occurring over the ocean. So various types of anomalous luminous phenomenon include most popularly the flashes or what resembles sheet lightning that illuminates the entire sky. Slow-moving globes of light, sometimes called slow meteors, bands or rays of lights in the sky, even columns of light that emanate from the ground. Flames, flame-like lights that shimmer, they could be small or they can be quite tall, also from the ground, and diffuse glows over mountains. But as the Daillaire event showed, that's not all. We also get reports of sparks crackling on high points. Sometimes that's related to radio interference that's recorded, like lightning during a rainstorm. And they have been reported before or during a quake or shortly after, and mostly in quakes above magnitude 5. They can last seconds to minutes in duration, and they can occur a few seconds to a few weeks prior to the main shock. And one estimate I saw from a researcher, he thought that maybe they occurred in only 5 to 6% of all quakes. So let's take a look at some examples of what these earthquake lights supposedly look at. There aren't that many pictures, but here are the ones that you will find. In 1968, there was a swarm of quakes called the Matsushiro events in Japan. And this swarm was a pivotal event in the story of earthquake lights because Mr. Kuribayasha, a dentist, took a series of photos in succession. This is one. But because there were photos in succession, you could see this sustained hemispherical glow and then a diminishment of that glow. And this lasted 90 seconds reportedly over Mount Kimyo, Japan. And other glows associated with the same swarm were said to last from 10 seconds to 2 minutes. John Durr of the U.S. Geological Survey was a proponent of earthquake lights in the 70s, and he considered this documentation some of the best evidence we had for them so far. And it was a Dr. Yasui who studied the reports of earthquake lights in Japan, and he brought these photos to the public in a journal article. And he also studied what he called spherics. I'm not sure if he originated that term, but the term spherics, radio interference associated in the 10 to 20 kilohertz range. It's July 1st in the Yukon, and these 7 luminous globes appeared on Lime Mountain, captured by visitor Jim Conacher. He thought he was seeing UFOs. He saw these balls of light traveling in an upwards motion up the mountain. A 6.7 magnitude earthquake occurred a month after. So these are the typical orb-like lights. There were no known causes for lights to appear here or to move the way that they did. This is my favorite photo of earthquake lights. It depicts this flame-like light. It's very spooky. It's very kind of spectral. This picture is not widely circulated. It's said to be taken 100 kilometers from the 7.2 magnitude epicenter, which occurred in the Vrancia Mountains of Romania in 1977. Most of the damage and loss of life occurred in Bucharest from, it was a vertical slip of a thrust fault, so it was very steep. And this photo comes from the Seismological Society of America Library, and it's said to depict accurately what the witness says he saw. Very strange. This is a rainbow cloud. It's a screen capture from a video you can find on YouTube from the Sichuan Wenchuan earthquake of May 12th, 2008. So this is an iridescent cloud. I've seen these before myself. You know, small ice crystals or water droplets act like a prism. You get diffraction and the scattering of light, and you get this very interesting looking cloud. Now, it's really not clear if this cloud is related to a quake at all, but the observers found it remarkable that they took a video of it. So it may be unusual enough in this area to take note. Now, there have been ground-based electromagnetic precursor observations in China for 40 years, and they recorded different anomalies near this epicenter of this quake than in the outlying areas 300 kilometers away. And they suspect that there could be a difference between what happens in the compressional areas versus the tensional stress areas. And the electromagnetic emissions were 3 orders of magnitude higher in relation to this quake than normal. And ionosons recorded a giant positive disturbance in the ionosphere May 9th, which is 3 days before the quake. And this cloud reminds me, I remember reading about Chinese folklore that told of clouds that look like dragons in the sky were indicative of a coming quake. So China takes these natural signs very seriously. And I'll give you another example of that in a bit. But besides earthquake lights, there's this other associated precursory phenomenon, and they're not systematic in occurrence either. They're not reliable, and they're quite diverse. So during the preparation time for a quake, rocks dilate and compress, opening and closing the tiny spaces in the rocks. So what you will have is groundwater level changes. Even earthquakes that occur far, far away, as the wave of energy passes around the Earth, you will see an effect on the groundwater levels. I know that when an Alaska quake occurs, very large, the Denali quake, when that occurred, we actually measured groundwater changes in our monitoring wells in Pennsylvania as the wave passed by. But near the quake, they can be extraordinarily high-level changes. There could be artesian effects. The well just suddenly erupts from an artesian effect. And there could be permanent changes in water flow patterns. Also, a radon release related to that dilation as well. And in Kobe, Japan, 1995, They measured radon increase several months before. It peaked 9 days before the quake at 10 times the normal amount. And radon emissions as earthquake precursors have been a focus for Japanese researchers. Radio frequency pulses and anomalies, ULF and ELF, several incidents of this have been reported in the literature, but they're often post hoc realizations that relate an observed anomaly to an earlier quake. Loma Prieta, California, 1989, 20 times increase in ULF energy 14 days prior that was recorded by Stanford magnetometer readings. And also note that changes in the ionosphere interfere with radio waves, which just suggested that that's related. And in Chile, 1960, an unusual radio event occurred 5 days prior to a large quake, and it was recorded on 4 receivers that were studying solar activity. So they weren't really, they weren't thinking about this at all. And at the time, there was no idea what had caused this weird event. It was so unusual that one of the researchers wrote a paper about it in 1963. It was only later on that he started hearing about a possible relation to quakes and updated the paper in 1982. And he reports that this same network never again caught a similar event. So very low frequency anomalies have been detected. The measurements on the San Andreas Fault in the 80s that detected electromagnetic anomalies just before the earthquake, that looked promising, but further studies were not promising. And the interest waned in that type of measuring. So related to the radio frequency is ionospheric coupling. A scientist named Sergei Polinets in Russia, in 1990, he coined the idea of seismo-ionospheric coupling for earthquakes above a magnitude of 5. And he was relating those to anomalies that he was seeing in the ionosphere. And the ionosphere is part of the Earth's upper atmosphere, about 60 to 1,000 kilometers altitude, ionized by solar and cosmic rays. And Russian and Chinese scientists are using remote sensing via satellites to look for this since the 90s. And they found some occasions where there seemed to be something strange going on by measuring total electron content in the ionosphere in the general area over the region of a preparing quake. And they suspect that there's this stream of positive charges released from the surface that changes the electrodynamic properties of the atmosphere. And these significant changes are noted 1 day to a week ahead, or sometimes months ahead. They show up, they disappear, they show up, they disappear. So no real way to categorize those. And it's also difficult to pinpoint anomalies when you have regular fluctuations due to solar events and other causes of disturbance. And of course, not all faults will produce this, especially ones that are underwater. Thermal anomalies, or this infrared anomaly, some of these have been spotted via satellite 100 to 500 kilometers across a few days before major events. And then they fluctuate and then they disappear. And what this is this causes an apparent increase in ground temperature. And I'll have an example of this. So residents report feeling that the temperature rises overnight before a quake, but it's not reflected in the local ground temperatures. Weather and atmospheric events, things like earthquake fog, are reported. Many people do talk about earthquake weather, which is kind of another thing, and that's really problematic and not consistent because some report that as hot and dry or as earthquake weather, and some report it as rainy as earthquake weather. Doesn't really correlate. But like Pliny the Elder and Aristotle long ago considered strange clouds as earthquake precursors. They wrote about that. Reports of atmospheric anomalies also include these things like flames from the tops of trees, which we sort of understand, and these earthquake meteor lights that travel very slow, not like regular meteors. Animal behavior, most of us have heard about that. There is some lab data on it, but there are tons of anecdotes about it. Almost every earthquake that you will hear about publicly, you will have somebody say that their animal reacted strangely to it or before it. But these don't have controls, they're not reliable. Now, fish and small mammals are particularly sensitive to electrical signals, and maybe other animals as well. Another interesting report that I'd seen was that there were people documented plants suddenly looked strange. They drooped before an earthquake. So I'm not sure what to make of that, but related are humans feeling unease, feeling ill before a quake. Again, the data is just not robust. And other spooky things happen. An interesting story I heard was about demagnetized magnets hours before a quake. Somebody had this big horseshoe magnet, and all of a sudden one day all the nails fell off of it. And they couldn't figure out what happened. They thought, oh, it just wore out. and then, a day later, they put it back up and it was magnetic just as usual. So we also get reports of radio and TV static, even computers acting up in the modern day. So interesting associated phenomenon. Historical reports, several of these are in continental areas, not subduction zones, and they seem to be mostly related to grabens, which are extensional features, extensional faulting features, and they're quite steep faults. They're not shallow. And of course, the early reports are vague. The more recent reports are less vague, but still very uncertain. So New Madrid was the Mississippi River graben, and luminous phenomenon appeared not only in the epicentral area, which was sparsely populated at the time, but also up to 600 kilometers away. People saw flashes in the sky, a glow in the sky, and 40,000 square miles of area was affected by this quake. So people reported these flashes were like explosions or sheet lightning, or they saw fires in the air from North Carolina, and also reported sparks from the earth. In Lisbon, which was an estimated 8.5 magnitude quake, 8 days prior, suddenly worms appeared all over the ground. Animals started to act strange. They reported strange lightning and flames appearing on the mountainsides where there was no fire. In Sonora, a very strong quake for this area. It was extensional, 7.2 magnitude, and extended into Arizona, the effect. And the old newspaper reports show that people thought there were volcanoes erupting. They saw what looked like blazing craters on the mountains. And eventually researchers found scorched trees over the fault. In Udo, in Japan, there were 1,500 reports of luminous phenomenon. And that occurred at 4:30 a.m., so it was dark. People saw the lights. And these were carefully recorded witness reports. The sky lit up. There were beams, columns, and fireballs of light. And a report of a series of round lights in a straight line in the sky, which I thought was really curious. So more modern, Haiching, this is the most remarkable quake. In December of 1974, there was unusual animal behavior noted by these trained observers. People were trained to look for strange things going on with the animals that could be a precursor to a quake. So the snakes came out of hibernation. It's winter. They came out of hibernation. They froze on the ground. That was weird. The rats acted drunk. Chickens and cattle were excitable. The groundwater levels changed. Springs became cloudy. There were lots of small quakes that occurred. And by February, these reports had climbed steeply in number. There were artesian wells. Pools had gas bubbles in them. On February 4th, an evacuation was ordered. And at 7:36 that night, a 7.3 magnitude quake occurred. And the evacuation was credited with saving thousands of lives. Not that long after, in Tangshan, fireballs and flashes were seen 200 miles away from the area where the next night a 7.8 magnitude earthquake also occurred, with 240,000 people died. So could these reports be tainted because we're dealing with memories of a tremendous catastrophe? Are they reliable reports? The Chinese instructed their residents to look for lights and precursory signals, and they reported them. Now in Saguenay, we had these 46 good reports collected during a swarm of 67 quakes. There were luminous balls, 1 meter off the ground, these motionless meteors popping out of the ground and just sort of hanging there. Some had streamers to them. There were rays and bands across the sky. And researchers found that there was a relation to these earthquake-like sightings with where the grabens were at the surface. In Kobe, 7.2 magnitude earthquake, people reported blue-white light streaks from the fault area a few seconds before the shaking occurred. The longest lasted more than 30 seconds, and white luminous hemispheres again appearing near the ground, but then these floated upward 100 to 200 meters wide. Some flashes were co-seismic, including some that were observed on a literal unindustrialized island. So we're seeing lights where there probably shouldn't be lights. And again, at the fault, plant roots were found scorched, and the minerals in the fault gouge were locally heated to melt the silicates that were in the minerals there. So I'm leaving many other events with reported anomalies out. There are lots in the literature. And the fact that they reportedly occur at sea, where people report glowing balls of light rising and then bursting on the surface, these disks of light. Are we seeing possible electrolysis of seawater? Are we seeing a response of self-luminous organisms? Is this something else? We just don't know. So let's step into the more recent reports where people have cameras at the ready. There's been a periodic resurgence in media interest in these. Whenever there's a large earthquake and somebody reports that they have film of earthquake lights, there is this resurgence by the media to talk about this topic again. In Turkey, people reported floating lights in the sky, but the sky and the sea glowed red, and there were lights coming out of the sea. And this was not the first time this was reported in the Black and Mediterranean Sea areas. It's happened before. In Peru, Lima security cameras caught light flashes as the shear waves passed. And you can go on YouTube and you can see this video. But the more interesting story was a Navy officer at sea reported blue columns of light bursting 4 times in succession from a rocky outcrop between his ship and the shore. So they were coming from that asperity, the uneven rocky structure. In L'Aquila, Italy, a study in 2010 by Fedani, he interviewed eyewitnesses and received 241 reports of luminous phenomenon, 1,057 anomalies in total. And this had a range of everything. This had flames coming from the ground, glows, flashes, fireballs, streamers like aurora, luminous clouds, and these pictures are taken from L'Aquila before the earthquake. The sky was reported red or orange with light violet clouds or fog, especially over the mountains. Electrical discharges from asperities, which are those rough or pointed surface. And a biologist noted that the toads that she was studying in this one local pond suddenly disappeared. She didn't know where they went. And then there was a 6.3 magnitude earthquake in April after several foreshocks. And then the toads came back. So Fedani did a survey of these anomalies after the event. And he stated that his aim was to instruct the public about earthquake lights. So he was not only collecting the data, but I think he might have been talking to the people at the same time. So there may be some confirmation bias working in that study. But there was one interesting story, really interesting story that came out of this. Carlos Stranella was a resident who lived near L'Aquila. And he already knew of this earthquake lights idea. When he saw flashes, he reacted. And I want to read the quote from the paper. At about 1:30 in the morning on 6th of April, just 2 hours before the main shock, Carlos Stranella saw 2 white light flashes reflected on the furniture of the kitchen, whose shutter was open. The second flash was intense as daylight, lasted more than 1 second, and left an impression on his retina. He checked that everything was fine in the kitchen, looked out the window and saw no stars, or he saw stars, but did not hear thunder. So then he remembered this earthquake light idea, the summary he had read a few months earlier, and he decided to take his family to a safer structure. And he noticed that the air temperature outside was much warmer than he remembered at dinner time several hours earlier. So there we got the earthquake lights reported and the infrared potential happening. So there were 71 flashes total recorded in L'Aquila during the main shock from a clear sky. And again, electrical discharge phenomenon and flames right before or after. And the flames were reported up to 10 meters high. But another interesting image was that people recorded small flames coming from in between the cobblestones on the street just before the main quake hit. Also noted were radio phenomenon, unusual sounds, fluid emissions, which I assume are springs where there weren't springs before, and 305 biological observations. So let's take a look at the photo evidence from two recent events. This is New Zealand, 2016. Now that we have all cell phone cameras, people rush out during a quake and take these videos. These are screenshots from a video. And in the video, you can see that these are just flashes. They're not sustained. They just flash and they disappear. So they're greenish blue. They were said to be over the sea, but that's disputable. This was a 7.8 earthquake that occurred. And of course, this is the kind of stuff that makes the news. This is what people see and now call these earthquake lights. Well, we're not really sure that they are. Let's go to Mexico City in 2017. These are 4 photos, still shots that I took from one video, and I just circled that double set of lights there so you can see that they were in different positions in the sky. They look basically generally the same. However, what this appears to be are transformers exploding, or electrical arcs where the wires touch, and you get what we know, you get very, very bright bluish white flashes of light. They reflect off the clouds. You can see there were clouds here. So we know it looks just like this. So we can't really say for sure if these are indicative of what could be earthquake lights. And now you're dealing with light pollution and urbanization, and you can't see any of these subtle earthquake lights that were reported if they in fact do occur. And also the Peruvian quake recently on YouTube, it could very well be electrical wire arcing or transformers exploding, which also happens during earthquakes. Things explode. So frustratingly, we have not seen the kind of unusual forms of earthquake lights that were reported in like Saguenay or in other places, or of the ground flames or fireballs or columns, unfortunately. Maybe someday soon. So the scientific view here is skeptical. And why is that? Well, it's because scientists are conservative, as they should be. Enough trustworthy evidence must be accumulated, and they don't feel generally that that high bar has been reached. Anecdotes, that's mostly what I just told you. That's the worst kind of scientific evidence. It can lead you where to look, but there's lots of noise and errors in that you have to sift through to see if there's anything really there. The complications, obviously, these are very hard to observe. There are multi-factors involved with whether you actually can observe them, and they're hard to record. And there's, again, those alternative normal explanations that may wipe out something more interesting. And not all situations are going to produce earthquake lights or related precursors of any kind. So it seems to be that these kind of precursors are an exception rather than a rule if they occur at all. And mechanisms, we have not come up with an explanation for how they could occur. We don't have a framework to hang these observations onto to make a coherent theory. And I'll talk about these mechanisms that have been proposed next. And then we have this association with spooky things, paranormal, and I'll get to that, but that makes scientists very wary. So traditional research in seismology has been focused on the mechanical observations, the ground deformation, the prior events. And these reported precursors are very diverse and they're hard to fathom. They could all be caused by the same thing. And what I found interesting was the tone of the researchers who are working on earthquake lights. You know, in 1931, there were these 1,500 reports, and some said at the time, 1931, there's no doubt these things exist. There we are in 1973, John Durr, USGS, called them well established in his paper based on the many documented reports. Here we are in 2018, and we're still not sure if they're well established or if they really exist. So not everyone seems convinced, and if we ask the USGS what their opinion is, they say geophysicists differ on the extent to which they think individual reports of unusual lighting near the time and epicenter of an earthquake actually represent earthquake lights. Some doubt that any of the reports constitute solid evidence, whereas others think that at least some reports plausibly correspond. So it's very wish-washy. We have to have a mechanism to concentrate and maintain large charge densities to reach the surface to make these lights. Charge accumulation and movement is the problem. But squeezing and grinding and breaking rock slabs and mineral grains on such a scale it would be surprising if you didn't get something electrical going on. So let's take a look at some of the mechanisms proposed. How do we get that electrical effect to the surface? If we can confirm that movement to the surface, then maybe we have a basis for the reports, and then they'll be more accepted. So an electrical mechanism might produce air ionization, electrically charged particles that act as nuclei for condensation, release the latent heat, and may have physical effects on animals and the spooky things like the demagnetized magnets. So streaming potential, where fluids are forced through small pathways that generates electrical charges, not high voltage, no way to get it to the surface. The most popular explanation used is piezoelectricity, but this has short decay and you have positive and negative charges being formed at the same time. If you have random distribution of quartz crystals, quartz is abundant, but the charges will cancel each other out. And we can't get it to the surface. Vaporization in shear zones produce charge separation and dramatically increase conductivity, but only if they're shallow can they travel all the way to the surface to produce a coronal discharge above the faults. So several geophysical factors at play here break this mechanism. And sonoluminescence also proposed. That's when an intense sound wave can cause gas bubbles in a liquid to collapse, produce this burst of light. This idea also didn't go very far. So all these things could be going on, maybe are going on, but they don't seem to be enough to produce what is observed as earthquake lights on a large scale. Now we have the best candidate for a mechanism, the peroxy defect theory. Friedemann Freund has been the discoverer and champion of this unifying theory, and he's combining ideas from semiconductor physics, chemistry, rock physics, into the idea of this peroxy defect theory. And he got to this via the semiconductor physics. He is not a seismologist, but all of a sudden he was getting this charge coming from his rocks, and he wondered if it was actually doing something in real life. So I'll briefly explain the peroxy defect theory. Bear with me on this. I'm going to go very fast. So the oxygen molecule is O2. It's negatively charged. It's typically linked with other minerals like silica and aluminum. So the peroxy defect is when the O2 in the mineral structure is replaced by an OO bond, which is very weak. But it's stable. It sits there dormant, but it is easily split. And these peroxy defects are in igneous and metamorphic rocks. So there's a percentage of this distribution in these rocks. Not so much I don't think they find it at all in carbonates or marble, but in the igneous and metamorphic rocks they do. So under stress, these bonds break and they release a positive charge carrier. It's called positive holes or p-holes, which flow. The positive charges flow via grain-to-grain contact, and they flow fast, 200 meters per second, and several kilometers if the chemistry allows. So you have this cloud of charged particles that can reach the surface and generate this local electrical field, and could cause this massive air ionization. Now, Freund says that this is what generates the necessary charge for observed earthquake lights effects and associated phenomenon. And he's demonstrated this in the lab and reports that at about 2 seconds before rock failure, he records a burst of positive ions from the surface. Now, he uses stress gradients, so he'll stress the rock on one side, and that creates the gradient to flow. It's not uniform loading. So if you imagine, like, okay, you've got a fault and there's a stress on the fault, the charge carriers are moving away from that stress. And maybe topography plays a role. The flow is away from the fault, and notably, he says the discharge may be concentrated at these high points on the mountains or asperities, rough points. And we know that pointed and irregular structures tend to concentrate that electrical field in the air. That's why you see St. Elmo's fire on the top of ships' masts in the old days. And from what I can tell, and I'm definitely not an expert in this, peroxies do not seem to be relatively controversial. Nobody's saying that they don't exist. It's how you translate it over to the idea of seismology and earthquake lights is where we get kind of lost. So Freund has a problem with scaling up. You know, he's doing these lab experiments. Is Is it really equivalent to what's going on underground? We don't know. But if this theory does hold, it could account for these lights of various kinds and the timing and the clouds or the fogs and the thermal infrared anomalies and the ionospheric perturbations and the animal behavior and even the everyday strange anomalies, because this cloud of electrically charged particles are leaving the ground surface en masse. So here's a simplified model of the subduction zone on the left and the Graben area on the right. Activation of the electronic charges via the mechanical stresses. S, the stressor, is the moving fault. We have the breaking of the peroxy bonds, the formation of currents, and the positive charge exiting at the surface, producing electric ground potential, infrared emission, air ionization, and increased ozone. And if you recall, the most significant electrical signal, he says, is seen before reaching rock failure, so just seconds before a quake. That does correlate with reported earthquake lights. And he also suspects that a passage of a shear wave, that energy may also produce enough force to break those peroxy bonds and manifest that energy at the surface. Daillaire's event? Maybe. And unfortunately, the charge flow could be focused in some areas, blocked in other areas due to the heterogeneity of the crust. But it is the most promising method proposed so far, but it's still just proposed. And Dr. Freund and his colleagues are having a difficult time getting a footing with many of today's seismologists. So why is that? Well, there's still this general attitude of non-acceptance of earthquake lights. And we still have the situation where they're not considered by today's seismologists to be important or meaningful or reliable. They don't yet fit into the picture. So they're not accepting of earthquake lights in mainstream seismology for the most part. And they're not really eager to support investigation into it, but several do recognize that it was and still is this unexplained thing going on in seismology. But because the mechanism isn't known, it's not considered credible. So the scientific data that's been captured so far has often been the result of some lucky observations or anecdotes, and we don't yet have these statistical meaningful data sets. One claim, which Freud himself has actually made, is that the phenomenon is observed so frequently that there must be something to it. That's like the Bigfoot argument. You know, everyone says they see it, there must be something to it, but I think it's more complicated than that. And what we have is a lot of false alarms if it's a common idea in the public sphere. If they see something, then they could report it as being one thing when it's really not. It's also not as prevalently reported in the US because of our geology here. 90% of such reports are in rift areas. And there are several anomalies that have been reported in California, but many of these papers regarding earthquake lights are published in China, India, Russia, Taiwan, Japan. So there's a translation problem. American seismologists are not necessarily seeing this work. And many independent studies seem consistent with the peroxy defect theory, the charge carrier theory, but the picture is still pretty blurry. And finally, you have the idea of earthquake lights associated with spooky things. So let's tackle that because I like spooky geology. So they earth lights are a bigger category. Earthquake lights are within the category of earth lights. So there's all sorts of earth lights that people report. And they've been connected to paranormal and fringe ideas. There's this obvious relationship to ball lightning, which is another thing that everyone thinks is real, but some people don't think is real, and we're not really sure what's going on there. How do these spheres stay stable? And could be that the glowing spheres of earthquake lights may have a similar manifestation phenomenon, but they have a different mechanism, and we're just not sure. Spook lights are a favorite anomalous phenomenon of mine. Many places are noted for their recurring phenomenon of floating balls of light. And it's been suggested that these locations are possibly related to seismic stresses or some other generation of electrical current that produces lights. Examples would be Hessdalen in Norway, Brown Mountain Lights in North Carolina, which the USGS did investigate as well. But the whole concept of spook lights is questionable, but it's a great tourist attraction, actually. UFOs. Now recall the observer in Tagish Lake called the spheres he saw UFOs. So if people see glowing light in the sky that's moving in a strange way, they might say, oh, I saw a UFO. And curiously enough, the Condon report in 1968, which was the government's final word on UFOs, explained some reports of UFOs as natural luminous phenomenon. So he explained one mystery with another mystery, but that was an easy out, I guess. The tectonic strange theory proposed by Michael Persinger. Persinger is a neuroscientist, and he proposed that fault areas produce stress-induced transient geophysical fields. No quake occurs, but the fields that are produced may affect the temporal lobes of the brain, the electrical circuits, and this could explain why people report they see lights, they hallucinate, they have bad feelings, they think their house is haunted, or they have strange electrical malfunctions. This is a beloved idea by many paranormalists because it sounds sciencey, but the data is not robust for this at all. Now, it's not far-fetched to suspect that emissions of radon or other precursors that go on could be causing transient electrical or magnetic disturbances, and there have been ghost-like claims of things in the house malfunctioning. Frankly, electromagnetic anomalies are more plausible than spirits of the dead, but we also have this connotation of earthquake lights being fire from heaven, bad omens, opening of hell, associated with superstition. So during a stressful time, people do report weird things, and they may get confused, or they may exaggerate what they saw, or they may misremember. So in its entirety, all these things are rolled in with scientists' perception of earthquake lights. So where do we go from here? Well, there's still a huge amount of work to do to answer the question, are earthquake lights real? Seismic events are relatively rare. We have limited ability to distribute the various equipment, the large number of variables to record, and non-seismic signals may precede large earthquakes, but not all quakes are the same. The crustal rock regime is not the same for each. They don't all produce the same precursor signals, or any at all, depending upon the conditions. So there's this lack of facilities to record earthquake lights or other environmental anomalies, and there is insufficient instrumentation to cover large areas for all the various parameters we'd have to measure. And even monitoring active spots, think about this, they know that a quake is very probable in a certain area. Even monitoring those active spots with equipment is expensive and difficult. And systems designed to detect anomalous fields have to be able to distinguish the normal from the anomalies. Quake Finder is in Palo Alto, California, is a private venture that is deploying magnetometers. They began in 2000. The USGS rejected their grant for money to do this, but their goal is to get those large data sets if they can and look for statistical significance and to obtain calibrated local background measurements and to get past the anecdotes. So since much of this work is going on in other countries, I think cooperation is necessary. We need those bigger, more robust data sets, and I think that those better results will give us a little bit better resolution to this picture of all that may happen prior to a quake, but there have been many misses, many failures that derail the progress of looking into this. And I think that it's clear, though, that other countries are moving down this path. They're looking at this new way. They're looking up to the sky instead of, under the ground to see what could be coming. And I suspect that there may be some more predictions soon. Prediction is fraught with peril. If you want to see a horror story about prediction, you could look up the trial of the scientists at L'Aquila, Italy, because they did not make a good prediction. And somebody in L'Aquila, Italy was also measuring radon, and he made his own prediction. He said there's going to be a quake, and there was a quake. But nobody listened to him. In fact, he was cited for public nuisance or something. So, yeah, prediction, scary. So to conclude, as a geologist, I love natural anomalous phenomenon, and I strongly suspect that there is much more we don't know and that we could learn about earthquake precursors. And we may have been looking in the wrong place, and we're not hearing the whispers that the Earth is telling us that something is going to happen. And I'm excited about what this field could bring in the future. I think we may eventually narrow and define some sort of forecasting for earthquakes better than what we have now. And perhaps the next big quake will bring more convincing evidence of earthquake lights and real warning beacons that we should heed. So I think that talking about mysterious things like this weird phenomenon, this is an effective way to get the public interested in scientific topics because they're highly curious about them. And I try to use these spooky topics to engage the public, especially children. And it brings scientific explanation to the public in a way that feels meaningful to them. They're interested in it. They could sort of understand what's going on. And if you're interested in more spooky geology ideas, this is my site. I'm developing this website, and I hope that teachers might use it to spur some discussion with their students. And it's also my personal site if you'd like to see what else I'm doing regarding science in the public. But it was my honor to be invited to talk to you today, and thank you everyone for coming to listen.